Hi, this is Ms. Nickel. This video is for students that are having trouble balancing equations, but especially for students that would like to make up a part or all of the balancing equations with Beads Lab, because you won't have your beads now. So I'm going to show you how to do this on paper, which is where we're headed anyway. Remember, balancing equations is all about the law of conservation of mass, which means we have to have the same kinds and numbers of atoms in the reactants that we have in the products. Okay, so steps for balancing equations. First thing we have to do is just count the atoms in the formulas on both sides of the equation. So first step for that is to set each atom equal to its subscript. And the second step then, if there are parentheses, you're going to multiply by the parentheses subscripts. So let's go ahead and see what that looks like on paper. So this is the first equation we have to balance on the Beads Lab Worksheet. And so we have nitrogen, we're going to set that equal to our subscript. It's N equals 2. And hydrogen, have a subscript of 2 also, telling me I have 2 hydrogen atoms. That's a diatomic molecule, meaning that it exists as 2 hydrogen atoms bonded together covalently. And then on my product side of this reaction, I have 1 nitrogen. If I don't have a subscript, then it's automatically a 1. And I have a 3 that applies only to this hydrogen, not to the nitrogen. So that is going to be H is equal to 3 on this side. So once I have set my subscript, my atoms equal to my subscripts, I have no parentheses here, so I can go forward. Let's look at what our next step is. So step number 2 is compare all of the atoms, or the number of atoms in the reactants and the products, starting with first element in the reactants. Okay, so that's going to be on the left side, and a couple hints are save hydrogen and oxygen for last when possible, and save single element molecules for last when possible. So this one's pretty straightforward. We're going to start on the left and compare our nitrogen. I have 2 here, but only 1 on this side. So now that I've compared, what is the next step? When comparing atoms, increase the coefficient for the formula that has less of that atom. So that's what we need to do here. Like I said, I have 2 nitrogens here, only 1 here. And how do I increase a coefficient? I'm going to put the number in front of the entire formula. That's what a coefficient is. So here I'm going to put a 2, but that means I have to multiply all the atoms in that formula by 2. So that's going to be my 1 nitrogen times 2 here, and my 3 hydrogens times 2, because now I have 2 molecules of ammonia. And so that gives me some new totals. I'm going to go ahead and write those out. I'm not going to circle them yet because I might have to change them. But I have a 2 and a 6. Then what I like to do is go back to the other side. So I'm going to respond to this change I made. My nitrogens are balanced now, but now I've thrown off my hydrogens. I have 6 hydrogens on this side, only 2 on this side. So again, I'm going to increase the coefficient on the side that has less. That's the same as adding molecules. And if I have 2 here, I'm going to have to multiply by 3 so that I have 6 like I do on the product side. So I have to figure out what to multiply this subscript by in order to get the same number of atoms that I have on the other side. That's going to be a 3. And so I put a times 3 here. This then is equal to 6. I compare my hydrogens. And then sort of your final step, just to make sure you've got everything right, you circle your final numbers on things and give them a little check mark just to show that you've compared. It's just sort of a bookkeeping to make sure you don't lose track of what you have. Okay, so then to review the steps that we went through, we counted the atoms in the formulas, and I'm going to post these steps online. We compared the number of atoms in reactants and products, starting with the first element in the reactants. If we had hydrogen and oxygen, which we did have hydrogen, we would save that for later, and also save single element molecules for last when possible. When comparing atoms, increase the coefficient for the formula that has less of that atom. multiply everything in the formula by the new coefficient, and then start comparing again. It's kind of like ping pong. You just go back and forth and make the necessary changes to balance. Whenever you change one thing, you're usually going to end up changing something else until you get to the end. Go back and forth adjusting coefficients until the equation has equal numbers of all atoms on both sides. And then this step we're going to talk about a little bit later, just making sure we have the lowest possible whole number coefficient for our formulas. Okay, so let's go to another example. So if we go through the steps, first thing we want to do is set each of our atoms in the formulas equal to its subscript. So here we have potassium equal to 1, and I'm leaving some space here. This is chlorine, Cl is always chlorine, equal to 1, and oxygen, though, is equal to 3 here. That's my reactants. I go over to my products. Potassium is equal to 1, and chlorine is equal to 1. Then I have oxygen here equal to its subscript, which is 2. So now that I have everything, all my atoms written out, I'm going to start on the left and compare my reactants and products. My potassium is the same on both sides. I'm going to go next to chlorine. I have 1 chlorine here, and that is the same. So the only thing left to compare is oxygen. So I'm going to figure out what I have to multiply this oxygen subscript by so that the resultant number will be one that both of these subscripts can divide into. So that's sort of a shortcut. We could go back and forth, and so we would add an oxygen molecule on this side and then come back over here and have to add another KClO3. But whenever you have a situation where you have an odd and an even subscript and you're comparing, you're going to have to find a number that both of them will divide into. In this case, that's going to be 6. So if I multiply the oxygen subscript 3 by 2, I would get a 6. And so I'm going to put a coefficient of 2 right there. And I'm going to multiply everything in that formula by 2. And on the other side, since that number is 6, I'm going to multiply oxygen by 3. That's a coefficient of 3. And I multiply by 3 here. So let's see where that leads us. We're going to end up with 2 potassiums, 2 chlorines, and 6 oxygens. And over here we have 6 oxygens. So now we can see that our oxygens are balanced, but our potassium and chlorine is not. So I'm going to go back over to this side. What do I have to do to increase potassium and chlorine? I just put a 2 in front of my KCl. Then I can multiply both of these by 2, and those will end up being balanced as well. Circle everything, do my check marks at the end, and that one is finished. Okay, let me just go ahead and pause this.